Okay, here is, we got everything done from 2.1a yesterday, talking about a lot of limits. I was on the previous video, and we got our work done to the very last example. And this is a pretty quick one that further talks about our limits, so probably worth taking a look at. I'm going to call this my blue function, and this one my red one, just to keep them separate. And if I was going to sketch this, maybe we'd create a T-chart, but we're just going to do mental T-charts. I would say, here would be my plan. I'm going to put 1 into this function, but I'm going to go hunting for that point with a circle. Right? Okay, so I put 1 in here, and I get 1 on 0, and 1 on 0 wants to be infinity. That kind of implies I expect maybe a vertical asymptote there. So I'm not going to put 1 in. I'm going to put 0 in. We're going to go less than. We put in 0. We get out -1. And let's just continue down that road. Let's put in -1, and we get 1 on -2. -1 gives us -1/2. And -2, we quickly find out, gives us -1/3, and -1/4, and -1/5. So there's asymptotal behavior this way. I'm careful not to let that pull away from the curve, or from the asymptote. We got asymptotal behavior this way as well. So now let's consider as we get closer to 1, but not quite to 1. For instance, if I put in 1/2, if I put in 1/2, I get 1 on -1/2, and 1 on -1/2 is 1 times -2. So at 1/2, I'm down here. And let's see, I've got 8. If I put in 1/8, or excuse me, if I put in 7/8, I get 1 on -1/8. But that's 1 times -8. So I'm right down here at 7/8. So anyway, there's our asymptotal behavior that we expected. So there's our blue graph. Red function. I'm going to go hunting for 1, and I'm hunting with a dot, right? Because I can be equal to. So solid dot if the point exists. Put in 1, I get 1, -2, -1, plus 5, 4. 1 gives me a 4, and that is a dot. I'm going to make it bigger than I normally would there. Just kind of emphasize. Then I put in 2, and I get 8, -4, 4, plus 5, 9. I'm already off the chart. I'm already up here. Is there a chance I'm going to come back? Well, I know these things wiggle around. Let's try 3. Put in 3, and I get 27 -6. Pretty clear I'm not coming back, am I? Because this x cubed, is it clear this x cubed has taken over? These become insignificant. Okay. So this thing is curving up and through that guy. It's certainly not a straight line, but I think that'll suffice. Okay. So determine a complete graph of f, sketch a complete graph, I think that means. Find the limit. And I'm going to rewrite this. This is approaching, as we approach 1 from the right. That's my red graph. I'm going to rewrite that. It should be limit as x approaches 1 from the right of f of x. So just one finger here, just one ET finger. We're approaching from the right until we get over to 1. And as I'm approaching over to 1, clearly, we are looking to arrive at 4. Okay? Then we are to find, also part of A, the limit as x approaches +1 from the left of f of x. So, now I'm approaching +1 this way, and all of a sudden, I'm heading down to infinity, negative infinity. Therefore, there is, oops, don't know why I didn't make that blue. Would have been nice. There is no limit. Don't say negative infinity. Say there is no limit, or limit does not exist. Any questions on that? Okay. Does the limit of f of x exist at 1? Now it's both fingers. This guy thinks we're going to be 4. This guy thinks we're heading to negative infinity. there's discontinuity. I had to pick up my pencil, and it's not just a hole in the graph, right? So I guess this is actually part B. Part C is no, and that's because we have such a good math word, discontinuity, or a jump in the graph, but I kind of like discontinuity. Is that clear? Okay. Assignment will not change as we move into B. This is the entire one assignment.